Hello, we've put this video together to help explain why we're expecting bigger floods with climate change, and also to help visualise some of the information that comes out of our flood and climate models. This is a catchment map, something that might look familiar from school geography lessons. Any raindrop that falls within the area of this catchment will generally make its way downhill, joining river channels that flow down towards the sea. The catchment for the River Thames is approximately 10,000 square kilometres. With significant rainfall events, millions of tonnes of water will make their way into the river system. These rivers can carry a lot of water, but if there's too much, it will flood out of these channels and into the surrounding landscape. We're going to focus in next to see what floods might look like in a particular location. Here we're looking at the river channel in cross-section. We're going to play a simulation of some flood data through this. At the moment, you can see the river is easily contained within the river channel. As the flood peak rises though, it spills out over the riverbank on the right-hand side, flooding into the meadows and the trees. To the left of the diagram, you can see what this would look like on a measuring stick. We actually use gauge boards like these to measure river levels. And in our illustration here, you can see this flood peak is now marked as the highest flood level that we've recorded so far. We're going to play through a few more floods now. We've simplified this so each rise and fall is just showing the biggest flood peak in a 10-year period. Actually, the river will be moving up and down a lot more as the individual years go by. You can see the highest flood level is being nudged up on the measuring stick as the decades move on. But not every time. Some decades will have bigger extreme rainfall events than others. This illustrates the natural variability that we see in the weather. You can also see that there are some big floods in here, with some inundating the houses on the left-hand bank. This second illustration is a sketch map of part of the river system. This shows the extent of the flood water it gained for the biggest flood of each decade. Even in decades with only small flood peaks, we'd expect the water to come out of bank in places. There are various flood meadows along the Thames, for example, where this is encouraged to happen rather than allowing the water to inundate a town, for example. Sometimes you can see that farmland is flooded, and other times you can see that houses are affected as well. Between each flood, the rivers are returning to their channels, but you can see the dotted lines shown on the map where the biggest flood extent is so far. The climate is changing. Global temperatures are now over 1 degree warmer than they were at the start of the 1900s. This is a change that's been driven largely by emissions of carbon dioxide from the burning of coal, oil and natural gas, as well as deforestation and other land use changes. Whilst there's a lot of discussion at the moment about bringing emissions down to net zero, we still have a long way to go. And every year at the moment we're pumping vast amounts of greenhouse gases into the atmosphere. This graph uses data from the 2012 Future Flows project. It shows the results of a model simulation of flood peaks for the River Thames at Kingston. We're going to show this sequence played out with the river cross-section and the map that we showed earlier. This is one of 11 of these simulations, and you can find out more information about this in the document that accompanies this video. It is by no means the most extreme of the set. Looking at everything together, we can see the sequence of flood peaks played out from the 1950s to the end of the century. It is important to remember what we are looking at a model simulation here, so the floods are not real events. This is particularly important to note for the period from the 1950s to date, which was used as a benchmark for the models to make sure they were working well. The modelers have worked hard to ensure that the natural variability is realistic. So, for example, the probability of having an extreme rainfall event that leads to a flood is correct in the model. However, it is then randomly simulated, like rolling a dice each time, to see how big the flood actually is in each decade. As the century progresses, the effects of climate change become more and more apparent. The probabilities shift, and floods that would have been considered big in the 1950s, 60s and 70s are becoming more normal by the end of the century. And by the end of the 21st century, we're seeing the chances of even bigger floods happening than we've seen before.